A fully loaded 18-wheeler tractor-trailer truck travels while exerting a 63,492 Newton force. The truck travels from 4.44 meters per second to 14.13 meters per second at 45 meters. What is the weight of the tractor-trailer? All right, I'm going to start with listing my givens. So here are my givens. I know the force, let's see, the truck is exerting a force of 63,492 newtons. I know it's going to travel from initial velocity. So the initial velocity is 4.44 meters per second to a final velocity of 14.13 meters per second. And it's going to do this in 45 meters. And the question is, what is the weight? All right, so let's start with the end of this problem. What is the weight? I only know one equation for weight, and that's W equals mg. So that's going to be my final equation I use to find the weight. But I need to know, I got to go into the mass. So to find the mass, I only know two equations with mass. One of them is weight. The other one is F equals ma. And I've got F, and with this other information up here, with these other variables, I can find A with kinematics. So I'm going to use F equals ma to find the acceleration. And then I use kinematics. I've got v naught, x, and I'm looking for A. So that means I'm going to use the equation v squared equals v naught squared plus 2ax in order to find the acceleration. But when I do this, I'm going to do it backwards. I'm going to start at the bottom and work up. So the first thing I'm going to do is find the acceleration. So up here, I'm going to find the acceleration. So v squared equals v naught squared plus 2ax. And then I'll solve this for a to isolate it. So 2ax is equal to v minus v naught squared. So a is equal to v squared, sorry, these are all squareds, squared divided by 2x. So the acceleration is the final velocity, 14.13 meters per second squared, minus the initial velocity, which is 4.44 meters per second squared. All that divided by 2 times 45 meters. All right, doing the math. The tricky part about doing the math on the calculator or whatever you're using is you got to put the denominator in parentheses or do the math in your head. 2 times 45 is 90. But a lot of times people don't do that and they get the wrong answer. They get the numerator divided by 2 and then multiplied by 45. So be careful when using the calculator. This gives me an acceleration of 1.99937 meters per second squared. Acceleration second squared. And I'm going to use all these decimals in the next calculation. So working my way up, next thing I'm going to do is I'm going to find the mass. Find the mass. I'll start with the equation F equals ma. M is equal to F over A. So M is equal to the force, 63,429 newtons, divided by the acceleration with everything that's in my calculator, 1.99937 in units, meters per second squared. And that is going to give me a really big mass of 31756.00314 kilograms. So there's the mass. Next step is I got to find the weight. There's only one equation for weight. The problem I'm having right now is screen space, so hold on a second. Ta-da, screen space, at the expense of some of my other work, but that's okay. So I'm finding the weight. So let's make a little notation up here. I'm going to find the weight. I know that weight is equal to mass times gravity. So the weight is equal to the mass that's given times gravity. 31756.00314 kilograms times acceleration due to gravity on the Earth, which is always 9.80 meters per second squared. That's going to give me a weight of 311,208 and some decimals, but I don't care about the decimals because I'm going to express this with 3 sig figs. So the weight is equal to 311,000 newtons, 311,000 newtons. Let's do this. So I've got to find the weight. W equals mg. Remember, I just found the mass to be 31756.00314 kilograms. So the weight is equal to that number, 31756.00314 kilograms. So it's equal to that number times the acceleration due to gravity on the Earth, 9.8 meters per second squared. And that gives me a weight of 311,208 point. A bunch of decimals actually don't matter because I'm going to round this to 3 sig figs. So 311,000 newtons. And that's the weight.